Hi students, this is Alex here. In this video, they have given solve the problem of the vibrating string for the following boundary condition. Let's take the wave equation. The wave equation is we have dou square y by dou t square equal to a square into dou square y by dou x square. And we have a suitable solution for this. The suitable solution is y of x comma t is c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Now we are going to use the first condition. So using the condition 1, that is y of 0 comma t is 0. It means wherever x is there, we have to substitute 0. So in these places, if I substitute 0, y of 0 comma t will be c1 cos 0 is 1 and sin 0 is 0. So we have only c1 here. And rest of the terms c3 cos pat plus c4 sin pat is written as it is. Now this value is 0. So 0 equal to c1 into c3 cos pat plus c4 sin pat. Now c3 cos pat plus c4 sin pat cannot be 0 as it is defined for all t. Therefore, the only option is C1 is 0. So, we get C1 as 0. Substituting that in our solution, we are going to get y of x comma t is, when C1 is 0, this first part will be fully 0. We will have C2 sin px into C3 cos pat plus C4 sin pat. Now let's use the second condition. Using second condition, y of L comma t is 0. So wherever x is there, we have to substitute L. So y of L comma t is C2 sin PL into C3 cos PAT plus C4 sin PAT. Now this value is 0, so we have to substitute 0 here. 0 equal to C2 sin PL into C3 cos PAT plus C4 sin PAT. Now already we discussed this cannot be 0. In the same way, we have another constant C2, and even C2 cannot be 0 since C1 is 0. Already in a term C1 is 0. So again in the same term another constant cannot be 0. So since C1 is 0, C2 cannot be 0. So therefore the only option left is sin PL must be 0. It means when sin theta is 0, theta is n pi. This is a solution. So PL should be n pi and P will be n pi by L. So using that in our solution, y of x comma t is c2 sin px, which is p value we have to substitute, which is n pi by L into x into c3 cos pat. So cos pat n pi at by L plus c4 sin pat. So n pi at by L. So we get the solution. Now let's multiply this inside. So y of x comma t is C2 C3 into cos n pi x by L into cos n pi, sorry, first sine we have, so sine n pi x by L, sine n pi x by L into cos n pi at by L plus, if we multiply with the other term, C2 C4 into sine n pi x by L into sine n pi at by L. Now let's take Cn as C2 C3 and Dn as another constant C2 C4. So our solution is y of x comma t becomes Cn into sine n pi x by L into cos n pi at by L plus dn into sine n pi x by L into sine n pi at by L. Now as a next step, we are going to apply the third condition. But in the third condition, we have the partial derivative with respect to t. So I am going to do partial derivative with respect to t here. So after getting this term, we can also take summation from n is from 1 to infinity, and even here summation from n is from 1 to infinity. Now let's find dou y by dou t of x comma t. We are going to differentiate this partially with respect to t, so x terms are constant. So we keep Cn constant, sin n pi x by L constant as it is. Then this term differentiation is minus sin n pi at by L into n pi a by L plus, coming to the next term, summation n is from 1 to infinity dn, again we keep sin n pi x by L as it is, and this sign differentiation is cos. So cos n pi at by L into n pi a by L. Now the condition is we have to take x comma 0 and the function is x into x minus L. Let's use t as 0 here, that is dou y by dou t of x comma 0 will be, when I put 0 here, sin 0 is completely 0 and cos 0 is 1. So first term will not be there, we will have only the second term, summation n is 1 from infinity dn sin n pi x by L into n pi a by L. Now let's take this as a constant bn, that is dn into n pi a by L as bn. So now this value, as per the condition, we have x into x minus L. So this is x into x minus L equal to summation n is equal to 1 to infinity bn into sin n pi x by L. Now this is the half range Fourier sine series. This is half range Fourier sine series. So we can find the constant Bn using the formula 2 by L integral 0 to L f of x into sin n pi x by L dx. So here this is 2 by L integral 0 to L is the limit. Function is x into x minus L into sin n pi x by L dx. So we are going to continue this integration. So before that, let's expand the term. For easy integration, let's multiply this. So this is x square minus Lx into sin n pi x by L dx. Now this is u and this is v. So u equal to x square minus Lx and v is sin n pi x by L. Now u dash will be its differentiation 2x minus L and u double dash will be 2. and v1 its integration minus cos n pi x by L by n pi by L, and v2 will be minus sin n pi x by L by n pi by L whole square. Now Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 dot dot dot. But anyway, here u triple dash will become 0 because differentiation of 2 is 0. So we have Bn equal to 2 by L. Now u, which is x square minus Lx. So x square minus Lx into v1, which is minus cos n pi x by L by n pi by L minus u dash. U dash is 2x minus L into v2. So v2 is minus sin n pi x by L by n pi by L whole square. Then plus u double dash. U double dash is 2. And we need v3. V3 is this integration. Let's write it here. Minus sign is cos n pi x by L by n pi by L whole cube. So here it will be cos n pi x by L by n pi by L whole cube, and u triple dash is 0. So now we have from 0 to L as our limit. Let's substitute the upper limit. When I put the upper limit L here, L square minus L square is 0. Here when I put L, sin LL gets cancelled, sin n pi is 0. So when I put here L, this is the only term remaining when I use the upper limit. So 2 by L, 2 and cos n pi, which is minus 1 whole power n by n pi by L whole cube. Then minus, when I put the lower limit, when I put here x as 0, totally it is 0. When I put x as 0, sin 0 is 0. So again the last term is remaining, minus 2 cos 0 is 1 by n pi by L whole cube. So after this we can further simplify by taking 2 common. Already there is a 2, so 4 by L and n cube pi cube by L cube, that L cube I take to the numerator. All these things can be taken outside. After this we have minus 1 whole power n, then minus 1 because 2 is taken common. So this is our Bn, and now we can cancel this. It is L square. So Bn will be 4L square by n cube pi cube into minus 1 whole power n minus 1. Now let's check for even and odd. If n is even, so like 2, 4, 6 dot dot dot, minus 1 whole power 2 minus 1, this will become 1 minus 1, so it is 0. So this Bn is 0 when n is even, and when it is odd, suppose if n is odd like 1, 3, 5, we take minus 1 whole power 1 minus 1, this is minus 1, which is minus 2. Already this is 4. So minus 8L square by n cube pi cube. This is for when it is odd. So we have Bn value when it is even and odd. Using this Bn, we have to find the value of the constant Dn, because in our summation we have Dn. So Bn equal to Dn into n pi a by L. So let's write it here. Bn equal to Dn into n pi a by L, and Bn is minus 8L square by n cube pi cube equal to Dn into n pi a by L. So from this Dn equal to, this L will get multiplied, so minus 8L cube by n cube into n is n power 4, pi cube into pi is pi power 4 into a, and this is when n is odd. So we got dn. This dn we have to substitute in our solution. This is our solution. Let's copy that. So we are going to replace this dn. So y of x comma t will be summation n is from 1 to infinity Cn sin n pi x by L into cos n pi at by L plus summation. Now n is from odd till infinity and we have dn as minus 8L cube by n power 4 pi power 4 a into sin n pi x by L into sin n pi at by L. Now we are going to use the fourth condition. Fourth condition is y of x comma 0 is this function. So wherever t is there, I have to put 0. Let's write it here using fourth condition. Now y of x comma 0, that will become summation n is from 1 to infinity Cn sin n pi x by L, and when I put 0 here, cos 0 is 1. So there will be only 1 plus when I put 0 here, sin 0 is 0. So totally the second term is 0. But the condition is y of x comma 0 is we have a function x and L minus x from 0 to L by 2 and L by 2 till L. So let's write it here. This is x when 0 less than x less than L by 2 and L minus x when L by 2 less than x less than L. So this is the function, and here we have summation n is from 1 to infinity Cn into sin n pi x by L we have. Now this is the half range sine series. I can replace this as Bn. So we have x 0 less than x less than L by 2 and L minus x when L by 2 less than x less than L. This is summation n is equal to 1 to infinity. Let's take Bn into sin n pi x by L. So this is half range Fourier sine series. So we are going to apply the formula for Bn, which is 2 by L integral 0 to L f of x into sin n pi x by L dx. But f of x is made up of two parts, one is x and other is L minus x. So let's substitute here. So Bn will be 2 by L integral 0 to L by 2. Our function is x and we have sin n pi x by L dx. Again 2 by L integral. Now we have L by 2 till L. It is L minus x into sin n pi x by L dx. Now we are going to use Bernoulli's formula. So this is u and this is v. So u equal to x and v equal to sin n pi x by L. So u dash will be its differentiation, which is 1. U double dash will be 0. v1 will be minus cos n pi x by L by n pi by L, and v2 is minus sin n pi x by L by n pi by L whole square. In the same way, this is u and this is v in the second set of terms. So u is L minus x and v is sin n pi x by L. So u dash is minus 1 and u double dash will be 0 and v1 will be minus cos n pi x by L by n pi by L, and v2 will be minus sin n pi x by L by n pi by L whole square. Now the Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So we come to the first term, bn equal to 2 by L u, which is x, and v1 is minus cos n pi x by L by n pi by L, and we have minus u dash, which is minus 1 into v2, which is minus sin n pi x by L by n pi by L whole square. And we have our limit from 0 to L by 2 for the first part. Then coming to the second part, again we have plus 2 by L, and this is L minus x into minus cos n pi x by L by n pi by L. Then minus u dash, and u dash is already minus 1, so we can make it as plus 1 into, again v2 is minus sin n pi x by L by n pi by L whole square, and limit is from L by 2 till L. Now let's apply the limit. We have to substitute L by 2 for all x. So this will be Bn equal to 2 by L. This will be L by 2 into minus cos LL gets cancelled, so we get n pi by 2 by n pi by L. Then we can make this as plus, and after that plus sin n pi by 2 by n pi by L whole square. Then applying the lower limit, because of this x it is 0, because of the sign it is completely 0. So lower limit is totally 0. Now coming to the second part, plus 2 by L. When I apply L for this x and this x, L minus L is 0. Sin, when I put L here, LL gets cancelled, sin n pi, which is 0. So upper limit is completely 0, minus lower limit I have to put L by 2. So L minus L by 2 is L by 2 into minus cos n pi by 2 by n pi by L. Then here it is minus sin n pi by 2, LL gets cancelled, by n pi by L whole square. So all the limit substitution is completed. Now 2 by L is totally common, which we can take it outside, and this term will be L by 2, and there is a minus sign, so minus cos n pi by 2 by n pi by L. So I can keep this as L square. Then sin n pi by 2 by n pi by L whole square. Then this minus gets inside, it will become plus L by 2 cos n pi by 2 by n pi and L square. And again this minus comes here, it will become plus sin n pi by 2 by n pi by L whole square. Now we can see these two terms are same term with opposite sign, L square cos n pi by 2 by 2 into n pi. So one is minus, other is plus, we can cancel. So totally the Bn is 2 by L, and these two terms we can add. So it is 2 sin n pi by 2 by n pi by L whole square, which is 4 by L sin n pi by 2 by n square pi square by L square. That L square I can carry here and cancel this. So totally Bn I am getting it as 4 sin n pi by 2 by n square pi square, and there is an L also. So 4L sin n pi by 2 by n square pi square. And even here, if n is even, so we get sin 2 pi by 2, then sin 4 pi by 2, n values are even, then sin 6 pi by 2. So all these things, sin pi, then sin 2 pi, then sin 3 pi, all are 0. So Bn is 0 if n is even, and it exists for odd 4l sin n pi by 2 by n square pi square when n is odd. So we got the value of Bn. This I have to substitute in our solution. That is, we had Bn here. So this is our solution. So Cn is Bn actually. So in this place I have to substitute the value of Bn. So I copy this. Now I am going to replace the Bn. Bn also from odd till infinity, like how we had Dn. So now y of x comma t will be summation n is from 1 to infinity 4l sin n pi by 2 by n square pi square, then sin n pi x by l into cos n pi at by l, plus coming to the second term we have summation. Actually this is odd till infinity. N is again odd till infinity. We have minus 8l cube by n power 4 pi power 4 a. Then we have sin n pi x by l into sin n pi at by l. Now the constants can be taken outside the summation. So finally we have y of x comma t. So here 4l by pi square is a constant which can be taken outside. Now we have summation from odd till infinity. The remaining terms are 1 by n square, because 4l by pi square we have taken outside. Then sin n pi by 2 into sin n pi x by l into cos n pi at by l. Then plus, actually there is a minus sign, so we can take this minus 8l cube by pi power 4 into a is taken outside. Then we have summation from n odd till infinity. After this we left with 1 by n power 4. So 1 by n power 4 into sin n pi x by l into sin n pi at by l. This is the required solution for the given problem.